Now let us see some applications of this total internal reflection. In nature also we can see this total internal reflection. I can give an example of mirage, which we observe in summer seasons. And also you might have saw the periscopes. In that periscopes we will use some prisms, and actually those prisms are called as reflecting prisms. So in this case also we can see this phenomena of total internal reflection. Also we can see the total internal reflection in the medical field. So if you want to picturize internal organs, if you want to see the picture of esophagus, if you want to see the picture of intestines, stomach, then we will use optical fiber cables. So this optical fiber cable, which is a cable which works on the principle of total internal reflection. So these are some applications of total internal reflection. So this total reflection not only used in some technology, but also we will see in nature. So let us see one by one. So the first one is mirage. Second one is reflecting prisms. Or you can write brilliance of diamond. We all saw the diamond. Third one is reflecting prisms. Fourth one is optical fiber cables. Simply it is called as OFC. OFC means optical fiber cable. It is simply called as OFC. So in this, total internal reflection concept is used. So the first one is a mirage. So which is a natural phenomena which we observe in the summer days. So thing is, this is actually happens in the summer season, and most of the time it is happen in deserts. So when the observer or any person who is very at a very long distance from any object, for example, if I say there is a plant, there is one plant which is in the desert. So what happens is a ray of light which is falling on that plant, and after falling on it, a ray of light will falls on the ground. So if the observer is looking at the plant, he feels like a ray of light or some rays of light which is coming from the ground. Or he can see image of that plant which is inverted one. This happens because of the total internal reflection. Then what is the reason behind this? See, we know that to undergo the total internal reflection, the ray has to pass from denser to rarer. But this is some reason how to say there is two mediums. See, let me give you this. During the summer season, what will happen is, since the ray is hitting the ground level air molecule will have the higher temperature. They are at the higher temperature. So that may be considered as a hotter region. As you go away from the ground, as we move away from the ground, the air will be cooler. So at the higher region, air is most cool than the air molecule which are at the surface of the ground. So this hotter air at the ground level, which will act like a rarer medium, and the cooler air which is above the ground, which will act like a denser medium. So, as you move from ground level to the higher level, the refractive index of the layers of the air will changes. Because as you move away or as you move up, the air becomes cooler and cooler. That is why they should have a different refractive indices. So we should know that as you move up, the refractive index changes. So the ground level acts as a rarer medium and the upper level will act like a denser medium. So the ray which is falling from that plant, which has to pass through, firstly it has to pass through denser medium, then it has to travel to the rarer medium. So if that ray of light incident more than the critical angle of the denser medium, it will undergo the total internal reflection.
Here you can see a plant over there and a person is there in front of it, and when he look at that plant, he see the images of that plant. Since this is because of the total internal reflection, so that he feels like a light is coming from the earth surface. Because of it, he will see the reflection of that light. Here also we can see reflections on the road. This is also because of total internal reflection.
So this is one phenomenon which we observe in nature. Second one is brilliance of a diamond. Diamond is a very famous for us because of its brightness. If the light falls on it, it will seems like very bright. Why it is so? Because the refractive index of this diamond, the critical angle of this diamond is very less. So if a ray of light enters greater than the critical angle on this diamond, then the ray will undergo total interreflection, which is inside that diamond. Because of that, once light entered, that will not come out of it. That's why that diamond will glow so bright. So that is why we are so fascinated about that diamond. And it is also a technique of a diamond cutter to make to create some critical angle. So this is about the brilliance of diamond, and which is a natural phenomena we see in our nature. So next application of total reflection is reflecting prisms. These are the prisms which is used in periscopes. You might have saw the periscopes in your olden days. I mean lower classes. So it was using two prisms which will give the same image without disturbing its size or something. So there also the process involved is total internal reflection. So the next one is optical fiber cable. It is simply called as a waves, which is very famous in the field of medicine, because while doing the operations, they has to see the internal organs. They cannot get into the intestine. They cannot get into the esophagus, or they cannot see the stomach. So, to picturize this, to see the problems in such areas, they will pass one wire, which is a cable, and that cable is called as an optical fiber cable. Then what that cable consists of, let's see. This cable has two layers. This will have two layers. This is the inner layer, this is the outer layer. This is the outer layer, this is the outer layer, this is the inner layer. And the inner layer is called as a core, outer layer is called as a clad and core. Okay, this Core is made from a material called quartz. Quartz means it is a glass. Okay. So it is made from glass. So what happens is when a ray of light is incident at an angle of more than the critical angle within this optical fiber cable, the ray will undergo total internal reflection. Okay. So this is the process which is involved in the optical fiber cable. So that once you send the light, it can travel to any long distance without or negligible loss in the form of energy. The loss of energy will be negligible one, so that you can transfer the light to any longer distance or in any kind of a curved one. For example, if you bend the wire like this, then also light can travel with the negligible energy loss. There will be energy loss, but it is in a very small quantity. So this is this optical fiber cable also involves the principle of total internal reflection.
We can clearly see in this picture.
So this is about some of the instruments as well as a natural phenomena which involves the total internal reflection. And in the optical fiber cables, this is a large application. See, it can be used to transmit the audio video signals. To transmit the audio or video signals, we can make use of optical fiber cables. And if you want to see the internal organs like esophagus, stomach, or intestine, the optical fiber cable is used. So these are the applications of optical fiber cable.